I've noticed that some people here are actually interested in electronics, which surprises me. Time for a little inverter fun. I was given this inverter, I think probably 10 years ago, by someone who couldn't get it to work. And kind of funny because they're an electrical engineer. But you know, it's easier to just buy a new one. And what I found was there was a little inductor down here, you know, one of those that looks like a resistor, and that was open. I had pulled this out of the bin because I needed a FET, and you can see I've removed one right here. I didn't want to spend any money on the project and use my good new stuff, so I always keep boards like this around. And you know, and this one's been sitting there doing nothing. And one of the things I've been thinking about is, you know, with a TL494, you have a dead time control pin number 4, and you know, you could modulate that with an op amp or whatever. It goes from about 0 to 3 volts. 3 volts turns the system totally off, and it'll go up to a minimum dead time when you get down around 0 volts. But so that approaches like 95% or 94%, something like that. I'm not sure, but anyways, if you were, you know, wanted to have a water heater, you know, one of these old inverters, you know, you can pick them up for, you know, 10 bucks, and especially often many of them are bad. The power section here that boosts the voltage up, they often go, so you know, you got some shorted FETs, pull them out, pull out all that other stuff. What's really interesting is that this H-bridge will work with almost any voltage, you know, once you get over a certain minimum. So I have this hooked up to a 14 volt supply, and so this is really kind of an easy mod. One of the wires going to the switch powers all the circuitry. The other one goes to the 12 volt power pin, and you just need to find the one that goes to the circuitry, and you can power that separately from any voltage. It's only about 50 milliamps, and you know, you can provide that from a small regulator from a much higher voltage. So one of the things you can do is you can run this right off array voltage. So you maybe have 60 volts, and this is what I've done. Is right here is the capacitors for the high voltage section. I just came in with a wire and connected onto the positive section. Now this one has a common with the negative of the input power. Some are isolated, you know, that's the only thing you got to worry about. But I've connected right on, so this is the H-bridge. The inverter will not be powered even though the drive will go to the FETs. And like, it's very low current. Right here I have a 27 ohm resistor. I just want to show you how little this takes. So it squeals a little bit while the capacitors charge, but we're running this lamp on 15 volts, and it's, you know, 150 watt lamp, and I'm only drawing about 50 milliamps going into the control section. So that's pretty interesting. At camp, I'm going to be running one of these direct drive LG high capacity washers, and they actually don't draw that much if you don't turn the heaters on. And so I'll be taking panel voltage, running them right into this. It doesn't matter if the panels are, you know, the voltage varies around a lot, because I'll be within range, and it's only going to be drawing a small amount from the power from the panels. But this allows me to run the washing machine without using any battery. So anyways, I got this thing out, and I was hoping it was a TL494 circuit so I could develop some other techniques for water heating. I mean, you know, this H-bridge, that provides AC, and you know, if you're running 150, 180 volts of array, you can feed right into this. You know, feeding on the output, you can put switches, the thermostats on the heating elements and not worry about high voltage DC switching. And all you need to do is control, you know, the dead time control pin or something else. You could also, on the output, if you didn't even want to dig in this far, you could put a one of these solid state triac modules on the output, and you could modulate the output with that, with you know, some of my other control circuits. So that's what I was hoping for. But anyways, the oscillator is a dual 556, and I don't know if you know how I feel about 555s. I don't like them in anything. That's because I was around when they first came out, and when they first came out, they had a lot of problems with latch up and false triggering. Never got over that. But hey, it's just an interesting idea. You know, maybe you can come up with something. I don't know. It just seems like a fun thing to do, and a lot of these inverters are out there for next to nothing. Something to play around with. Thanks for watching.